Oh gosh. Okay. Hi everybody. My name is Tim. I am going to be talking about web scraping today. So this is the 5th session of learn.py. So yeah, let's just get going. Oh, feel free to. I will try to keep an eye on chat, but my screen real estate is not super plentiful. But yeah, if you have questions, please just bring them up. Thank you, Nare, for the links. Here they are in slide form. So if you want to follow the slides or the README, then you can go to these links, which Nare already dropped in the chat. The README is really nice. There's some stuff in the README that actually won't be like verbally going over. So if you want some more details, it's a really good resource. So if you follow like the membership portal, the code for this today's session is web snaking. And then obviously the feedback form, we really do appreciate it if you guys take time to fill it out after the workshop. So I'll try to plug that again at the end. But it's there for your convenience right now. So yeah, and then I don't know if Nara, if she dropped those links. We can, yeah, she did. Okay, great. All right, so web scraping. Now, this is the 5th out of 8 sessions. So here we go. So just to get a sort of overview of what we're going to be talking about, kind of the big points are: what is web scraping? Why would we use this? And then like installing relevant stuff. So for like our first part, we're going to be doing a little bit of a demo in the second half of the workshop, and for that we'll be using Selenium. And then I have like an additional thing that I wanted to talk about called reverse engineering, which we'll need the requests library for. So we'll go over installing those. Then we'll talk about some basics of Selenium, and finally the demos that I talked about. Okay, so what is web scraping, right? Like what kind of are we doing when we say web scraping? In short, we're trying to extract some data from the web, particularly this is usually web pages. Usually this process is automated, also wouldn't be all that useful. And the kind of process is you search like kind of the DOM or like the page for information we want. So this usually involves kind of sifting through HTML to find text on the page that you care about. One way I like to think of it is if you hired like your little brother to go and search through a bunch of pages and like lift a bunch of data into like a spreadsheet or something. It's like an automated version of that. So a quick note, web scraping kind of exists in this like legal gray area. So there are some kind of ethics that I want everyone to keep in mind. The first is like don't spam websites. When you're scraping, you have to request the web page. And if you do this too frequently, it can be really annoying for people who are providing these like websites. Don't steal people's data. So obviously, like don't take data from another site and then put it on your own as if it's your data, because it's not. And then don't look at private data. So that one's kind of self-explanatory. Just kind of basics. Okay, so a really quick aside, I did mention reverse engineering kind of at the beginning, but these 2 bullets are things that you might be able to try before web scraping. Web scraping is a really versatile tool, but sometimes it's not the most efficient. So if there's a web API that like a website will provide for you, and it gives you exactly the data you need already in a format that's really nice, you might want to try using that first. And then the other idea is reverse engineering, which is similar. It's effectively boils down to figuring out how the web page you kind of want to scrape works, and then limiting the amount of requests that you're making to only what you need. And we'll go over that. Okay, so to kind of reiterate the goal, write a program that can automatically find useful information on web pages. Okay, so the first thing we kind of want to do is install some stuff. So requests in Selenium are both Python libraries, and they're pretty easy to install. If you're on Mac, you can just say pip3 install and then request to Selenium. I think on Windows you omit the 3, so it's just pip install. So there's that, and then there's kind of this Chrome driver, which is a type of web driver. And we'll need that because what Selenium effectively does is like puppets a web browser and kind of makes it the web browser do what you want it to do. So in a way, Selenium provides a interface to programmatically control a web browser. And to do this, we need a web driver, which we use, this Chrome driver. I'm going to really quickly actually go over just downloading this because there is a little bit of weirdness. So for me, I would just go, you see drivers, and then I'll just choose Chrome. And then it tells you like, oh, depending on the version you're using, you want to use a different version of the WebDriver. So I can just go like, oh, what's my version of Chrome? Click this about. And it's like, okay, this is version 90. So I'll click this one. And then I'm on a Mac, so I'm going to click this one here. And the weird thing about this is, so we can go and unzip this. The weird thing that I noticed is you kind of just drag it where you want. There's another way to do it. We can put this in like a system path, and some more complicated stuff will happen that lets us access it like between projects. But for the purpose of this demo, like I'm just going to make a folder where I'm going to have my demo. I'm just going to call this, I already used actual demo, actual demo. And then in this folder, I'll just drop this. This is where my code is also going to be, is this folder. And then, yeah, and then the other things we need to install are just Python libraries. So you'd want to do these commands. So like with respect to that, if you want to follow along, you'll have to do these commands, and then you have to download this. All right. So some groundwork. This is just so some things that are going to be helpful to know as we are doing any kind of parsing of HTML pages. And the first big thing is trees. So a tree, you can think of it like a family tree. So you have kind of nodes, which are these circles. Let me see if I can get you have these nodes, and then each node will have like edges that go to other nodes. So you can think of this like as a parent and then a child, and then like here is like a parent and then a child. This is important because how we will navigate HTML pages is like an element will have like child elements, and we'll kind of go through this tree when we search for stuff. So HTML, the big things we need to know, we don't really need to know everything about HTML because that would be its own workshop. But what we do need to know is the basics of what an element is. So this thing here is one element. It has an element name, which we will also call a tag name. And then it has one or I guess 0 or more attributes, which have a name and a value. And the other important thing is that like an element will start with this kind of tag here, and then it will end with kind of this slash tag name. One of the big things to pick up is, and we'll go over this a little bit more, is that you can have elements inside of other elements. And that is what creates this tree structure. So yes. So here's a little picture to like kind of understand how HTML relates to trees. So we have this like web page here. The HTML code for that is right here. You notice that, for example, inside of this HTML tag, we have a head tag. Inside of the HTML element, we also have this body element. So we look at HTML here in the tree, and it has two children, head and body, which each have their own children, until we get to the bottom where maybe we have some text. One last thing about HTML. There are two very special attributes called ID and class. These have special meaning when we're talking about CSS, which is used for styling pages. But what we really care about is that an ID will uniquely identify a specific element, and a class will identify a group of similar elements. So they're very common. It's very common to search for an element or a collection of elements using an ID or class. Okay, so we talked about HTML, kind of touched on CSS. JavaScript is a little bit of an annoyance when it comes to web scraping. And the reason is because commonly pages are rendered using JavaScript. If you've ever seen React, the React library, React will kind of we'll have it send JavaScript to the client, and then that will build the page by running some React code that's in JavaScript. And the problem for us is that now we can't just request an HTML page and expect the entire page. The website might try to send us some JavaScript. So we have to have some way of running that JavaScript. And the solution to this, at least for us, is going to be Selenium. So effectively what Selenium will do is we can say, okay, I'm just going to have Selenium talk to Chrome, and Chrome can get the page and run the JavaScript and then tell us what does the page look like after. And then we can search through that page, which is really nice. So before kind of going over that, does that make sense to everybody of like why we use Selenium? If you have any questions, feel free to like put them in the chat or something. I will try to keep an eye on it. But otherwise, I will continue. So just to get an idea of like, this is sort of a preface to the demo. I just wanted to explain kind of what some common, I guess, code from using Selenium would look like. So here are three imports that at least I'm going to be using. The first one here is just the WebDriver is pretty much one of the most important things. That is the object that we interact with to control the browser. This options thing will be used to configure our WebDriver when we load it up for the first time. And then this by class will provide us with some kind of constants that will help us search the page. And we'll see how that is used during the demo. Okay, so navigation, once you load a page, like kind of the next thing to do is to kind of search through it. So this is creating the WebDriver. And then we'll have getting a page here. And that's just whatever your WebDriver is, .get, and then a URL. And then these two methods will find either the first element of a certain kind or a list of elements of that kind. And this is where the the little like by object comes into play. So how this works is you'll say your like driver.get element or get elements. And then you'll say like, what are you searching by? In this case, I chose tag name. And then you can say like, oh, get the first element that is a table, or get all elements that are a table row, or this tr element. So yeah, this is the way I showed before. You can get an element by tag name. And then we see that we can get an element by class name and even an ID, which we talked about before. There's a lot more as well. So I included in the slides, I included a link for kind of other ways of doing it. One of the common ones that I've seen that I'm not actually going to go over is called an XPath. So if you want to check that out, you can follow this link. Okay. One last thing is there's this kind of text, like idea of an element's text. All that means is when I say some HTML element dot text, we're saying I don't care about any of the tags. Just give me the text that is rendered on the page. So I had an example here, which would be like, oh, okay, we say we got some element by ID, and then we say, okay, the text is equal to that element dot text. And it would do something like change this element into just this text. Okay, so this is kind of the bridge. After this, we'll have a demo. So I thought this would be a good time to just take like a 5 to 10 minute break. And if anyone had any questions, I can answer those. So we're gonna pause for like until like, I don't know, 6:26, unless one of the directors wants me to pause longer. Otherwise, I see a chat message. Slides link are broken. What? Okay, hold on. We could take the break to fix them. Actually, I think I have them. What do they link to? If they just like rickrolled you. Weird. This is easily fixed. Feel free if you have any questions to post them in the chat or even speak up. Otherwise, we can... Oh yeah, and I'll pause the recording. We don't need the break to be recorded. Okay. So here we go. So we'll just dump. That's funny. We'll just jump right into the demo. So effectively what the demo is going to be is scraping this site called MTG Stocks, which seems like a weird site. It's, if you couldn't tell from my previous slides, I'm quite obsessed with Magic the Gathering, and card prices will fluctuate in a very interesting way. If you like ever study economics, they sort of follow a lot of like patterns, which I find really interesting. So this is a page we're going to be scraping, and it's effectively, it is a page and it looks at the changes in prices from the last like day, and will highlight cards that have went up or down significantly in price. So yeah. So the goal, write a program that looks at MTG stocks and tells us if any cards we care about have changed in price recently. There's kind of two parts of web scraping, at least in my eyes. The first part is when you look at a page to try to figure out how is this page structured and how are we going to navigate it when we're web scraping. And then the second part is obviously writing the scraper. So I'm going to go to this link. Let's see. Okay, hopefully it opened. So this is the page we're scraping. So you can see it's just kind of like a table, and it has a bunch of different cards that have went up. There are actually two tables here. It compares since like last week, and then this one is since yesterday. We're going to be scraping just this yesterday table for a secret reason that I might disclose later. But one of the handy tools is when we want to see how the page is structured is the Chrome developer tools. And you can open those by right-clicking anywhere on the page. Oops. And then clicking inspect here. And that should open up a tab. And I really care about kind of this table. So what I will do is just kind of click this button up here. And then just click on like the elements that I care about here. Okay, so we have a table, right? So when we are trying to find this, we're going to look for something with the tag of table. And it's actually pretty simple how we're going to look through this page. We're going to look for a table, the first one, and then we're going to look for the body, and then we're going to iterate over each row. Each row is a card. In each row, it has these TD elements, which are kind of like, for our purposes, are kind of like columns. And each one has some information that we care about. So that is kind of how the scraper is going to work. So yeah, so let's try starting it. So I'm going to go over here. Now, the people at Hack said, as I was kind of showing them this workshop, they said, Tim, you should use light mode because it's easier to see. And I will begrudgingly do that, even though this makes my eyes kind of want to cry a little bit. Oh, God, it's dry. I feel like a vampire when you just open the blinds. Because I'm cool, Nari, that's why I use that theme. But so we're gonna make a file in here. This is just whatever folder you want to use, but I would do it in the same folder as you put Chrome driver. And I'm just gonna call this scrape.py. Alrighty. So we're gonna go through, we're gonna say, so the first thing we need to do is our imports. So what we want to do is import, and then I actually have to look this up because I forget. Some of the imports are really long and I actually kind of forgot them. So let me do that really quickly. But yeah, it's 3 imports. They're on the slides. So yeah, I actually kind of made a boo-boo in my planning though. So let me undo this. Oh God. Oh God. Okay. I will just find the I guess I just have to mooch off of this one. I already did this. So this is all code. These are the imports we need are from here. Don't want to look at that. Yeah. So we went over these in the slides. So yeah, you should just use dark mode and then make us invert our colors on our big brain. Okay, and then I actually really do have to find something on one of my other devices because otherwise this is going to be really hard to walk through with you guys. So allow me to do this really quickly and then we can start. Effectively, what's going to happen is we're going to have 3 like main things. We're going to have 1 class and 3 functions. One of our functions is pretty much going to be the lion's share of the app. It's going to do all the scraping and give us a kind of array of card classes. So like effectively what it's going to look like is say like class card, and then we'll have some like initializer here. without this because we're not subclassing from anything. And then one of the other things we'll have, so I'm just going to put a pass statement here for now and write to do. Effectively, what I am doing is pass is a special Python command that just says do nothing. You usually don't need to use it, but there are some cases where it is actually useful to have. The next thing is we're going to have a function, and it's going to be called get cards. And I believe this takes no parameters. So that's that. And then I'm just going to put a pass here as well. And then we have, I think this one we call find favorite cards. And this one's going to take in an array called favorite cards. So that's that. And then we're just going to go through and fill in these functions. So yes. So for the find favorite cards function, literally what this does is it calls get cards and then filters through for the cards in our favorite cards array. So get cards is going to do most of the work. So what I'm going to delete this for now. So the implementation of this is going to be pretty much we're going to say cards is equal to get cards. And then we're going to say for each of these cards, just use our trusty for loop. If this card, and then we want the name of this card. We didn't really define like what the card is. So obviously in here, our card is going to have to name at least, right? So for now, I'm just going to say self.name is equal to empty string, and we'll fill it in later. And then we just say if card.name is in our favorite cards. If it is, we'll just print something for now. So I'll just say, I will explain this because I think some people don't know about format strings. We'll just say, whoa, card.name changed in price. And then it's like, oh, wait, by how much? So obviously we're gonna have another thing called, I'm gonna call it change. And we're gonna just set that to 0 for now. Yeah, actually we might actually just make it a string. And then we'll say change by card.change. Okay, so this kind of makes sense, right? We get all of our cards from the site. We loop through them. This doesn't have much to do with web scraping. This is just sort of, we have to do this so we can know kind of like, so we can actually output something. So probably the next thing we want to do is flesh out this card class. So what's kind of the meaning of all the stuff I'm putting here? It is actually on one of my browsers. Let me move this one. Just these columns. So we have a name, we have a set, a new price, an old price, and a percentage. And we're literally just going to have all of these be in the card class. It's just a convenient way to store it. So I'll say self dot, I'm going to call this release set. And we'll just set this to nothing for now. And then we'll say self dot new price, I think, is equal to empty string and then self dot old price. So obviously we need something here. What we need there, we don't really know right yet, quite yet. So, but we're gonna fill that in, so don't worry. So that's all of these things here. Okay, so you'll realize why we made this class. It just makes things a lot easier. We won't have to deal with kind of this gross array stuff or this gross list stuff. Okay, so let's get into the meat of what we want to do. So the get cards function, we're gonna say this looks at this link. And then it will return a list of the cards in the first table. That's all this one does. The filtering of like finding what our favorite cards are will be done by this function. Alrighty. So the first thing we need to do is actually create this kind of web driver. And we can do that by making this options object. And this thing is what we did up here. We imported. Let me make this text a little bit bigger. I just realized it might be small for some of you guys. Okay. So this is our options object. We're just making one of them here. After that, we're going to take our options object and add an argument, which we can do with this function. And the argument that we're going to add is headless. But for now, I'm actually going to comment it out. We'll see what this does. It's actually kind of cool. So yeah, I will run this once without headless and once with headless. And then we actually make our WebDriver. So we can do that. We can say WD is equal to WebDriver dot, and we say Chrome here because I'm using Chrome. The arguments for this, one of it is the path to the driver. So instead of actually just typing it in here, I'm going to make a constant. So we have this kind of line. I'm going to make a constant up here. I'm just going to call it driver path. And I'm going to say, oh, where is my thing? It's just in the same folder. So I can just say /Chrome driver. And then, because it's in there. And then we say, we put the path in here. So web driver path. And then our options. So we say options is equal to, and then our options object. Great. Okay. Now, one of the people in Hack, they brought up, oh, Tim, wait, because it's important to have this statement at the end, we want to say .quit after we're done. So we do some stuff, do stuff, and then we want to do this quit method, or else it never closes the browser. And we all know how much memory Chrome uses. It became a problem for me when I forgot to do it. He said, Tim, why don't we use this special with syntax that we learned about when we were doing finals? And I said, when we were doing like file. And I said, oh, that's ridiculous. The WebDriver doesn't support that. And then I ate my words. So you can do that. You can say with WebDriver as WD. And then you can eliminate the statement. And now during this kind of with block, we have this WD, which is our WebDriver. Perfect. Okay, so a little bit more setup. One of the things I'm going to say is WD dot implicitly wait, and then I'm going to put in 15 worked for me. What this is going to do is tell our WebDriver to hold its horses when we're loading a page, instead of saying, oh no, I couldn't find the element you're looking for before the page is done loading. It's going to wait a little while until it decides that it couldn't find an element. After that, we're going to get the page. So this is this URL. I'm just going to copy it from here. And then we're pretty much set. And now we can start looking for stuff. So with this get function, we have the page. Now what we want to do is find the table. If we look back here, that was our first kind of thing, is this table. So what we do want to do, we find the first table, and then we find the body, and then we iterate through the browse. So let's do that. First table, we can say tables. I'm going to find all of them first, just for the sake of kind of being able to play around with all of them. But I probably won't be using the second table. So we say, not driver, I named it. We say find elements, And then we say by tag name. And the tag name is table, which we saw from the previous thing. So this will give us a list of all of the tables, which should be of length 2. To get the body, what we're going to say is body is equal to tables, but the first one only. And then we'll say dot find element. And there's only one, so I will just do that and say by tag name. And then we say I think T body is the tag name. Yeah. And then finally, we get our rows. So we say rows is equal to body dot find elements by tag name, and then row. So that's TR, I think. Yeah. So you can kind of change these. There's also you can do, I think, these 3 lines with a thing called an XPath, but I'm not going to go over that. But it might be a more concise way of doing it. And then the one other note is the only reason I have a subscript here is because I used the find elements function previously. Okay, so we finally have all of our rows. Now we need to loop through each row and kind of parse out all of the cards. And we can do that by, we'll just make a cards array and it will be empty. And then we'll say for row in rows. So our row will be each row. I'm just going to say that the columns of that row is going to be all of the elements. So find elements with the tag name of TD, which are, if we look back into our thing here, here's one row, and then here's like a column with this TD tag. Okay, so we do that, that's great. The last thing we want to do is we say cards.append, and then we want a card object, right? We want to use the card class that we made. So, okay, how do we do that? We need to construct it somehow, but we didn't decide how we're constructing this. So, the way that I want to do this, we don't know yet. Let me actually just say that we're going to print something here, and then we can decide what we want to do. So what I'm going to print is, we have a bunch of TD elements. I'm just going to show you guys what this is. So we'll say, I'm going to do a list comprehension. And I want to show you this text method that we did before. Oops, I did not want from, I want for. And then we're going to print that and then see maybe how that could help us. So we'll end up returning cards, but we didn't really add anything to it yet. So that's like our one thing that we have to do. But I'm going to try running this. And it should, I think, do what we want partially. Yeah, okay. So we can run it. Oop, I'm in a different branch. That's awkward. CD. Right now I'm just in my console. I'm just going to the folder that my actual demo is here. So it has a really long name. And we're going to say Python 3 scrape.py. And then we're not doing that. Oh, wait, did we print anything? Oh, you know what? We didn't call the function. That's a classic me mistake. So we're going to do, we don't actually need to print it. Find favorite cards. I'm just going to pass in the empty array because it doesn't matter yet. Or the empty list. Okay, this is kind of interesting. So it's actually loading up a Chrome browser, like a Chrome tab, which I found kind of interesting that it does this. But like the default behavior is that, oh yeah, and then it's going to do a lot of printing. But so if we look, the default behavior is to, where's the Chrome tab? Oh, it closed. Is to open a window of Chrome, like physically. which we don't really need. We don't need it to do that. So I'll talk, that's what the headless thing is for. So we'll try that after we complete the program. So we notice that when we do our print and then the text for each column, we get this really nice, like this really nice kind of thing here. We get this list of lists, and or this list, and it has name, set, old price, or new price, old price, change. So here's what we're going to do, right? We're going to say cards.append, and then indent this. And we're just going to pass this array in here, like the entire thing. We'll pass the list in. It's a little hacky, I will admit, but I found it to just be kind of convenient. And then up here, we're going to say list from website or list from site. And we literally just say, okay, and then this is like the first element is the name. And then the release set is the second one, and so on. Okay. So that should kind of just copy this sort of list here into like each correct category. Alrighty. So that should do what we want. And now we return more than an empty list. So let's add a card in here. I'm going to add one that I know has changed, which is Primal Amulet changed. I love this card. Okay, Primal Amulet, we'll say. And then we'll do one that like never changes, which is Ripjaw Raptor. It's one of my favorite cards, but no one cares about it, so it stays like 2 cents forever. All right. And let's try it again and hope it doesn't crash. Oh, it's gonna open up a Chrome browser again. I'll show you it without it. It does this, it loads the page. And then if we go back, oh yeah, it's gonna take a little bit to actually iterate through all of the stuff. But then it goes, whoa, Primal Amulet changed in price by plus 18%. Glad I already have one. So yeah, that's the program. And now you're thinking, you might think, oh gosh, it's really annoying that it opens up a tab of Chrome every time. That's what this headless argument is for. So if we uncomment that and then rerun the program, you should see that it actually doesn't open up a window of Chrome. It runs in the background. This is a feature I've always wanted, but I think the last time I used Selenium, I don't know if Chrome supported this headless mode. So I kind of forget. I might have just not known about it. But then we get the same output. Oh my gosh, it changed in price by plus 18.28%. And that is pretty much like the main program here. Before I go on to some kind of additional like kind of tips with the web scraping, does anyone have any questions about this program? A valid question is, quote, what? If someone has that question, I can go over it again. I've definitely had just, I don't understand. So there's no shame in that. I feel like that's the best question. Someone asked, why is the Raptor card so bad? It's not. It's a 4-mana dinosaur. It has decent stats, and whenever it's dealt damage, it draws you a card. It's just there's so many better cards and like so many ways of killing it without damaging it that it's not guaranteed to get you value. It's good in dinosaur decks, but yeah, outside of that very fringe archetype is not very good. If that's the only question, I will go back to the slides and we can talk about some additional stuff outside of this demo. So here's where I left off. Okay. Oh, we got one more thing. So one thing you might have noticed, you might say, Tim, there's no way that MTG stocks is going to change between the time that like you run your program and 5 minutes later. Like it probably won't change. So why do you keep asking MTG stocks, oh, what cards changed in price since yesterday on the same day? You know, like I don't need to ask them every 5 minutes. So one of the things I could do is instead of asking them every time, I can remember what they told me. And then if I run the program 5 minutes later, I'll say, oh, I already know this. I don't have to like make a network request all the way to MTG stocks and have them tell me what it is again. So we don't need to run it. We don't need to make the request to MTG stocks every time we run our program. We can store the data for a little while and then just use that if it's recent enough. This is caching. It's a very common type of thing. So what have we learned that could help us with this, right? File IO. Wow, I spent so long on this GIF, so I'm gonna spend a few seconds on this slide just to appreciate it. Yeah, this was from a previous session. I just want to mention it. There's other ways you can do it, like any data persistence method you can use. So if you want to use a database, go for it. If you just want to use a file, that's what I did. You can find that on in the repository for this workshop. I think I called it like scrape with caching or something. And it shows like how to kind of do this caching thing. But I just want to mention that you do want to cache. It's very not only considerate to people who you're asking for data, but it is also useful for you because when you cache, it is way faster. The program runs a lot faster. So yeah. So yeah, scrape with cache is what I called it. Yeah, so go see that if you want to see how it's done, but I'm not going to talk about it verbally. All right, so the last thing that I am going to talk about is called reverse engineering. And this is very interesting. This uses my favorite tab in Chrome Developer Tools, which is the network tab. So effectively what we want to do is we want to ask, how does MTG stocks, how does that page get its list of cards in the first place? Because clearly it's not just sending me a big HTML document, or we wouldn't have had to use Selenium. So it has to make some kind of request to get its cards. And then the question that comes from that is, couldn't we just do that? You know, why don't we just make that smaller request instead of making the big fat one that for the entire page and then sifting through all this HTML code? So what we're trying to do is sidestep Selenium completely. So the goal, write a program that gets the cards from MTG stocks without requesting the entire page. So the first thing we do is instead of inspecting the kind of elements tab, we're going to look at the network requests that MTG stocks makes when it loads the page. Then we write a program that will make the correct request and read the response. So that's what the slide says, not all that creative. This is the last thing. So let's go show the browser. Okay, so if you forgot, you can open this tab. You can either right-click and click inspect. I think on Mac, you can also do Command Option J, opens the console. And then now we go to the networks tab. And this is really cool. So when we reload the page, it will put in all of this sort of these requests. So the one drawback of this is it is quite intimidating. There's a lot of stuff that just doesn't matter in here. So one of the things I usually do is try to sort it by file type, because I know that like a GIF I don't care about, you know, like a PNG I don't care about, script you usually don't care about, style sheet, who cares, right? What we're looking for is data files. So that includes one of these like XHR files, and it might include one of these fetch things. I think sometimes they're useful. However, they're not, not this time. So if we sift through this, eventually we find this one called average. Let me expand this. It's like kind of small. Let's see if I can make this bigger. And then I will, okay. Looks like this is kind of as big as we can really make it. We see this average thing here, and we see this normal. This is a big list, what this is, this normal thing here. So when this request gets made, this average, it gives us back this little object that has like average and then normal, and then this big list. So what's stored in this list? They're cards, right? We have the percentage change, is it past price, present price? And then we see the name. So this is just a basic swamp, which is kind of funny. And a few other things that will be important is this include default thing, which I'll explain later, and interest type. So if it's day, it's in the top table that we care about. If it is week, it's in the bottom table that we don't really care about. So, okay. So this is useful. How do we get this? I want this. I don't want this whole website. I want this specific thing. If we look at headers, it's right here, request URL. And it's a GET request, which means it's like kind of easy for us to do. I didn't talk too much about request types, but like every time you like do like www.google.com, you make a GET request to Google. It's like part of how the sort of web requests work. And usually when you make one request, like to maybe MTG stocks, your browser ends up making several, which is what we're seeing here. So what if we just copy this and put it into our browser? Oh, this looks awful, but it's actually beautiful, I promise you. This is just pure data. It's great. So part 2, right? Let's write a program, looks at this and parses through it. We're going to find out like a few kind of nifty things. So let's just start that. So how I talked about requests earlier, the requests library. So we're finally going to use that now. So I'm going to make a new file in my folder. I'm going to call it scrape_re for reverse engineering. And then the first thing I'm going to do is import requests. And what requests does is literally just allow you to make a web request. So you can say like, hey, some like URL, and then effectively you literally just get back what Chrome gives you back here. The reason requests works right now is because this is obviously not rendered with any fancy CSS or JavaScript. This is just a JSON, what we call it, like a JSON object. For those uninitiated with JavaScript, a JSON is kind of like a dictionary in Python. And that's actually kind of how we'll end up using it a little bit here. So the architecture of this program, it literally is just going to be one function. It's going to be look for favorite cards. And what you're going to notice is that this is going to be a lot simpler. So pretty much the 2 steps of this is make request to get that big kind of JSON that we saw, and then look through it. That's the 2 things we're doing. And this function will take in a list of favorite cards. All right. So the first thing we're going to do is we're going to say res for, this is just for response, but you can name this variable anything. And we'll say requests.get, and then the URL. So what I'm going to do is just go to this other page next to me. And then I'm going to copy this URL. Okay. That does like kind of half the work. So next we're going to do JSON equals to none. And the reason we're going to do this, you'll see later, is we're going to try to set this variable to something. We're going to try and say JSON is equal to res.json. I actually don't know if you even need to do this. I forget if try except limit scope or not, but I'm going to do it for now. This line might not be needed though. So we say JSON, we try JSON is equal to res.json. If this fails, we're kind of out of luck, right? If this doesn't work, there's nothing we can do. So I will just print not a JSON. And then I will return. I'll return, do we return anything in this function? I don't think so. So I'll just return nothing. Okay, so now that we have this JSON, what our JSON is pretty much a dictionary. So how do we look through it, right? Well, let's check. So I'm actually going to look at this interface because I think it's better. We want what's inside of average, and then we want inside of normal. So the first thing we're going to do is say cards is equal to JSON and then average normal. And then this will get us that big list of cards, which is exactly what we want. The next thing we want to do, we want to add two constraints to the cards that we're looking at. We care, if we look back here, we care about cards with an interest type of day, and we care about cards that have this, where is it? Include default is true. And the reason we care about the include default being true is that we kind of want to pretend that we are like scraping like normal. And the include default will tell if it's actually going to be in the table. So we're going to do those two things. Let's say cards is equal to, and then I'm going to use, we haven't gone over this, but it's a cool function and I want to use it. It's filter function. Filter function takes in two things. It takes in what we're going to use a lambda and then some iterable. So that will be a list for us. And so I'm going to say lambda, and then it's going to take a card, and what it's going to do, what it's going to do is to check. It's going to say that card. We want to check if its include default is true. So that's inside of the print, and then include default. Okay, we say, is that true? So we can just use that as a Boolean itself. And then we say, is the interest type equal to day? So we also want card that interest type is equal to day. Okay, this might be a little bit confusing, so I'm going to explain it. And then this last thing is just going to be our cards list. So what is this doing is for each card in cards, only include it in this new cards list if its include default is true and if the interest type is equal to day. Otherwise, cut it out of the list. After that, it's actually really easy. Now we can just say for card in cards, and we kind of just do what we did before, but in a slightly different way. So we say if card print name is equal to, or not equal to, I'm sorry, is in our favorite cards, then we will print kind of the same thing. So we say like, oh my God. Then we'll use our nifty format strings, which I'm not sure if I actually explained. Format strings are really nice because you can put variables inside of these curly braces. That's kind of what they do. You put an F outside of here, you put the string, and then that will make it so inside of these curly braces, you can put a variable, like, for example, card, and then print name. And then we can say changed by And then this will be, I think, card percentage. Nice. Okay. And then I'm just going to add a little percent sign because I think it doesn't include it normally. So let's close this. So yeah, that is that. And then we can call our function. And we say favorite cards. And then I'll include probably just the same one. So primal and ulit and rip draw Raptor. Okay, let's try running this. Great. Uh-oh. Hold on, I have a syntax error. I actually don't know what it is. Oh, is that the very end? Oh, did I used, oh, I was running it with Python too. That's my bad. And then it works. And it's so much faster, right? It's like really speedy compared to the other one. This is slow. Like, so that's the benefits of reverse engineering. So yeah, I'm not gonna wait for this to finish. That is all I have. So yeah, this is reverse engineering. We did all this. So yeah, if you can fill out our feedback form, that'd be super cool. But that is all I have for you guys. So, oh, one thing I do want to mention, Selenium is really slow. I found a new way of kind of working around it because we don't need the interactivity of Selenium. So you can actually just have Selenium dump out all of the HTML and then use a different library called Beautiful Soup to parse through it. It's more efficient. I included a demonstration of that in the repository as well as I like updated the README on a branch called Soup, if you care about that. So yeah, because if you do find Selenium to be kind of slow, Beautiful Soup is good if you don't need some of the more advanced features that Selenium provides. All right. I'm going to put on, I want to put on different persona music. Hold on, let me, oh, I full screened the slides in two separate. Hold on.